This is Mr. Anderson for Math 122 Trigonometry, and today we're going to look at some problems from Chapter 3, Section 1. We're going to learn a little bit about inverse functions of sine, cosine, and tangent. Now, the inverse function is not to be confused with the reciprocal function. So when you have a function, a common mistake is that people might think that the reciprocal function is the same thing as the inverse. So for example, the inverse sine function is not the same thing as cosecant. Cosecant is the reciprocal function, not the inverse function. But the inverse function has some cool uses. For what we can do is we can actually find values from the angle measures and vice versa. So this function, it equals, if you want to show what this is equal to, and by applying an inverse, we would switch the x and the y, and then we would solve for the other variable. In this case, if we do that, we're going to find out that the inverse of sine of x is the same as x equals the sine of y. This is when your x variable is between -1 and 1, and your y is between -π/2 through +π/2. So let's explain a little bit what this means here. What this means is that you are going to be working within either the first or the fourth quadrant. So this is going to be quadrants 1 and 4. Because if you look geometrically at the sine wave, and you will actually see how it reflects itself over the y equals x line, as the book does in this section here, you're going to see more of why the domain and range x and y have to be within this scope here. The same patterns occur similarly, but not quite the same with cosine. The inverse of cosine, we're going to switch the x and y here again, and that gets rid of the inverse right there, because to find an inverse of any function, like we did in Math 121, where we turned an exponential into its logarithmic inverse, is we switch the x and y, and we go solve for the other variable. This is still between -1 and 1 for my x variable. But in this case, for cosine, we're going to actually be within either the first or the second quadrant, between -1 and 1 on my x, so that's, or -1 and 1 on my y, so that's going to go between 0 and pi. So we'll be within our first and second quadrant when we look at our cosine. And tangent, a little bit different. Again, you'll see the pattern of x and y changing place, removing the inverse of tangent, except that tangent actually doesn't go between 0 and 1, or -1 and 1 like it would on a unit circle. So the unit circle has, the lowest point for the x and y is going to be 0 and 1 when you go around the circle, but for tangent, it can be go from -infinity to +infinity. And you can see, when you looked at the graphs that we made back in Chapter 2, you can see that those did go to infinity. And so therefore, sorry, that's my x. There we go. And then my y would go between -π/2 to π/2. Notice that, like before, these are not equal to's, because we can't actually get to infinity, nor can we touch the asymptote lines. And I think you might be saying, but aren't the x's and y's backwards from what we see on the graphs that we made? And they are backwards because these are the inverse functions. They aren't the actual functions themselves. But just to kind of put things in perspective, this is going to be from quadrants 1 and 4 here. Okay, you just saw a quick edit because I accidentally wrote down the wrong thing at the beginning of this problem. So what we'll do for problems 1 through 6 is I'd like to do these without a graphing calculator. I want to do these with the unit circle in front of you, so if you could get a unit circle out, that would be a big help to you. So we want to find out the inverse of cosine at 1. So what you might want to do is you might want to go to any part of your unit circle here where the cosine is equal to 1. Now, we have to look in the first and fourth quadrants. So let's go and check out on our unit circle where the cosine is equal to 1. And that's right there at 0 on my circle right there, because this is the point. This point is 1, 0. So at how many degrees or radians, and in this case all of these answers are going to be radians, how many radians where will I be at when I'm at the point 1, 0? Because this is 1, or for my x, on cosine. And so the answer to this problem will be 0. That's right, that's going to be 0 because that is going to be 0 radians when cosine is 1. So this inverse cosine is just asking when it is. So this next problem is saying, okay, well, when is cosine equal to -1? And that would be here on the unit circle, and that's at -1, 0. And since we have to be for cosine between the first and second quadrant right there, we're going to be okay on this side here. So the answer to this problem is going to be tangent, the inverse tangent, -1 here. So what we're going to do is look where the tangent is equal to -1. So what I'm going to do here is draw a line. Oops, excuse me here. Now I know the tangent is -1 when I'm at this measurement right there, which is going to be at this -pi/4 rotations. Because tangent is equal to 1 at 45 degrees and at a -45 degrees. So we can get to this -1 here by going in this direction. Now, some might ask here, well, should we put down -pi/4 or should we put down 7pi/4? Because if you take a this counterclockwise rotation, it'll be 7pi/4 going in this direction. We want to use the negative because that would fit in for our bounds right here for our problem between -pi/2 and pi/2. So this answer is going to be -pi/4. All right. So let's go look on the unit circle here where √3/3 is for the tangent, and we can see that is there at pi/6. Now this right here is negative. This is a negative angle of -√3/2. What we can do is we can pull the negative out to the front because of the even odd rules and just find out where √3/2 is on sine. And √3/2 on sine is going to be at pi/3. But if we pulled the negative out to the front, we just put a negative right there. The even odd rules are pretty nice in this situation here. And the negative √2/2, this is kind of neat because we can pull the negative out in front again, and we know that's pi/4. So we pull the negative out in front again, -pi/4. You could also show it like I could have shown you here on this graph by going, instead of a positive √3/2, I could have rotated it this way for my -pi/3, which would be about right there if I was trying to be accurately writing the angle. And this is going to be -pi/4, so it would be down here. Again, -√2/2 for sine. The next piece I'm going to do here is the calculator work for this page. And the calculator work for this page is just to round the expression to do decimals. Now, a couple things here too is you want to make sure, since all of these are in radians when you turn your calculator on, you're going to want to make sure that your mode is in radian mode. Because these inverses are in radian mode, we can now use the inverse functions on the calculator and get 2 decimal approximations, or round to the nearest hundredth. So this is 0.6, and this will give you an answer of 93 hundredths. We can do this for all of these problems by clicking the second key, and this tells me at 20 or 0.2 or 2/10 the inverse of this measurement right here, the inverse tangent of this location is going to be this many radians. All right, so then we go to sine. I like the fact that it puts the parenthesis there, making our fractions pretty easily. That's going to be 13 hundredths. And then we're going to go to tangent, -3. And this you're definitely going to be using a calculator on this part. 1 and 25 hundredths. -1, excuse me. Then we have the cosine, which is going to be -0.44, just typing in the problem, number 11. This is 2 and 3 hundredths. And then we have inverse sine. Now, careful here on your notation here. This is square root of 3. Close that off, divided by 5. And for good measure, I'm going to close that off too. And this gives me 35 hundredths. All right, well, thank you for watching.